Boom. Hello and welcome back to Calculus 3. Now we're going to discuss 13.3 double integrals in polar coordinates. Or over polar coordinates, whatever. So now, first, we remember polar coordinates, hopefully, as r comma theta. And if you had, let's say, 3 and pi over 3, the way you graph and the way this works was you first draw radius 3, and then you swing that to pi over 3 angle, and that point is right there. And then if you, now this is still x and a y, is just a different way to get to a location. Rather than counting x's and counting y's, we get to draw 3 out as a radius and then swing for whatever angle. So you can go negative, you can go positive, positive angles, counterclockwise, negative, clockwise, and so on. We can convert between two realms using equations r cosine theta and y equals r sine theta. So this clearly takes polar into Cartesian because you have r and theta and you're making x's and y's. Or we are using r equals square root of x squared plus y squared, and theta equals inverse tangent of y over x, which converts Cartesian into polar because you have x and a y and you are calculating r and theta. So with a little bit of common sense, we get those. So those are our conversion equations, very important. Now we are moving to calculus portion, where we said that if you have some kind of a, let's say, slice over here, and you want to know the area of that slice, you will use that the area is equal to 1/2 integral alpha to beta of f of theta squared d theta. Now, before you jump and start screaming, whoa, hold on, that's 3D. It's not 3D. Theta is not a dimension. You have to know that. Theta is in radians, and radians is ratio of inch divided by inch, which means it has no dimension. It's a ratio. So d theta doesn't bring dimension to a table like dx and dy do. All of your dimensions are here, which is function squared. Now, further, these guys, along with that, is bringing pi into the game. And you have your we know that r is f of theta, so technically this is your r squared, and the pi will come from d theta. So now if I want to find this, this is where my alpha and beta angles are. All right, so that's alpha angle and beta. Well, actually, you know what? It's better if I draw these. That's alpha, and that's beta. This curve here is r equals f of theta. I'll make sure this works. Yep. So what am I going to do now? I'm going to do pretty much the same manipulation like we did in Calc 1 from single integral to double integral. I'm going to write that the volume, and I'm going to specify this time so there's no confusion, the volume over the region of f being given as r and theta over here, dA, can be found by this means for we still call it rectangular region, but it's actually a circle. But more general case is the one that we are interested in most of the time and worry about most of the time. And this is where you have g of theta and h of theta in the limits. So this is the one that we most of the time work with. That is equivalent to the general regions for this, for the rectangle. So say we have some kind of paraboloid. So here's a paraboloid. Let's say this point here is whatever, number 12, whatever. So the equation for this, if that's 12, must be z equals 12 minus x squared minus y squared. Let's say it's a circle on the bottom. We can further figure out the radius of this if we want to by setting z equal to 0, right? That gives us the level curve at the domain xy, which would give us 2 root 3 as the radius. Take square root of 12. But what I'm interested here is the volume of this. So the first thing that I notice is the circle on the bottom. Circle means rectangular with the air quotes, right? Rectangular region. So the volume for this would be the following. Function in terms of r and theta, r d theta, and I have to have alpha and beta, which is thetas, and then a and b, which is the radius. So now what should I do? First of all, I see that my function is given as x and y, but I need a function in terms of r and theta. So if you want to convert this, you would say that r squared is x squared plus y squared. If you put minus signs everywhere, then negative x squared minus y squared is equal to negative r squared. This means that my function z, which is the function now of r and theta, is 12 minus r squared. So what I did is I converted the function, which was this paraboloid, I converted the function which was given in Cartesian coordinates, in rectangular coordinates, into polar coordinates. So now when I write the volume integral, I say, all right, I want the entire thing. So 0 to 2 pi. You can decide to start on x and then go counterclockwise, and you see that it's an entire circle. Radius, because I picked 12, because I don't think about things, has to be 0 to 2 root 3. Again, I got this one by saying z equals to 0 to see what's happening on the base. The function is clearly 12 minus r squared. We just computed that. And then I have r, dr, d theta. By the way, this string is something that you must know. And there is no changing order of integration here. So we do not change this x as a unit, as a group. We do not change the order of integration. And now what's left is just Calc 1 to integrate all of this. The integral over here is, well, you have 12r, so it's going to be 6r squared. And then r cubed, which is r to the 4th, so r to the 4th over 4. From 0 to 2 root 3, and I still have d theta to deal with. So 0 to 2 pi, and then plug in 2, that's a 12 times 672, plus r to the 4th, it's 1, is that 36? Let's say it's 36. And 2 root 3 to the 4th power divided by 4. I said let it be 36. So that's 108 theta computed from 0 to 2 pi to give us 216 pi. So the volume of that paraboloid should be 216 pi if the 36 calculation went well.
Shouldn't it be minus? Or like, because in the beginning it's 12 minus.
Oh, yes. Yeah. Yeah, it's minus, so it's 36. When you subtract, so it's 36 over here. Well, thank you. And then 36 times 2 is 72. Good catch. You passed the test. So that takes care of that. But then, how about having a stencil of a flower, and then you want to know what's the volume of the cookie? See, these are the things that you can do as you hang out. Let's say the Thanksgiving thing, and there is the the cookie cutter, the stencil is the flower. You're the only one who can figure out the volume of that stuff because you took Calc 3, you know. No?
I mean, maybe if it was for Easter, I feel like Easter's.
Yeah, I'm out of the examples because now you're just. So let's take a look at few interesting examples. By the way, did any of you guys read the project and you know what's happening on the Okay, good. You'll figure it out. So let's see. The problem says that you are supposed to calculate the integral over general region R that has dA over 1 plus x squared plus y squared, where R is given as 1 less than R less than 2, and then 0 less than theta less than equal than pi. All right, so first of all, if you are to just forget about the region over there, and you're looking at this, there's no way in hell we can integrate this. There's no u sub or anything like that that works there, because it's over x squared and y squared in denominator, right?
Instead, x squared plus y squared equals y squared.
That's what we're going to do. So we are going to convert this one into polar coordinates, and then when you have 1 over 1 plus r squared, it is
Oh, it's tangent. Inverse tangent.
you solve this. So the first thing that we are spotting here is that x squared plus y squared is r squared. So this integral is going to be, oh, actually, there was almost that. Because there is r, the theta. There's this r here, which does what to the problem? No. What does it do? Anyone? U sub makes it even easier. I'm happy that two of you could remember the arctangent on 1 over 1 plus x squared, but now it's even easier. So I need the 2.5, and there we go. What do I have? I have 2r dr. And when I plug in 1, I get 2. When I plug in 2, I get 5. So the entire integral is going to be pi over 2 ln 5 minus ln 2. Nice. Always keep conversions in mind. Let's see this one. Negative 4 to 4, 0 to square root of 16 minus y squared of 16 minus x squared minus y squared dx dy. You got this. So where do we start? What do we do first? What do you think? Well, that's actually going to be later, but I need to convert this integral, right, into polar integral, which is making it in terms of r. But what do I have to do first? Because now I'm going to deal with limits and stuff like that. What do you guys think? Any conversion or changing of the order or anything like that has to start with drawing the picture from what you already have. You see the 16 minus y squared, and that's actually x equals that. That's a circle. Now we need to see if it's a half a circle or a full circle, but so we have x equals in terms of y. That means cut this way. This side is x equals square root of 16 minus y squared, and this side is x equals negative square root of 16 minus y squared. Do I shade the entire circle, or do I shade half of it? Half. So now when I'm setting up my double integral here, sure we have 16 minus r squared dr, no r dr d theta, don't forget that r. That's all cool, that's quick. The issue is limits. Now r is the inner one, and we know that's 0 to 4, that's the radius. But do you see what's happening now with the theta? Remember that theta starts 0 is here, and pi over 2. So?
It would just be negative pi over 2 pi over 2.
Bueno. Now you should not have any issues solving this. That should be, just setting it up. That's the big deal. Draw the picture from what you have in your limits currently. Has to have functions. That means you'll be able to draw. And then, once you have that done, you'll be able to transform the integral and solve it. Could we integrate? Yeah, and most likely, we would end up with some kind of trig sub to finish the problem off. But if you can convert it into polar coordinates and make the joke out of integration, why not? Right? That was the idea, the motivation. So let's do one more, and then we'll do something else. All right, so let's see. Integral -1 to 1, integral negative square root of 1 minus x squared to the positive square root of 1 minus x squared. Inside is x squared plus y squared raised to the 3/2 dy dx. Draw the picture, shade what you need, and then go on from there.
So 3/2?
Yes. So what's the shape? Unit circle, right? So we draw a unit circle. And then what do I shade?
Maybe? Oh, yeah,
Both.
both. Ooh. Yeah, that'd be from 0 to 2 pi.
Yes. So this one is 0 to 2 pi, radius is 0 to 1. R squared raised to the 3/2 times R dr d theta. And that's going to be 0 to 2 pi, 0 to 1. These guys cancel, so R to the 4 dr d theta. You know the rest. So for those of you who don't remember, when you use the polar coordinates, you can graph and you can get some very interesting graphs. So some of those very interesting graphs are the little flowers and things. So let's say y equals 4 cosine 2 theta should give you a flower that stretches out to 4. Like this. Now that could be your domain over which you are integrating. This is why I said a stencil, right? For cooking. You know how tall the cookie is, that's your z equals, and then the shape of the base is going to be in the limits. So if I am to take a look at this and say, you know, just simply z equals to whatever, 1/2 inch tall cookie, we can actually compute the volume of it, because what I have is I have the integral 0 to 2 pi to draw out the entire cookie, because that will draw the entire flower. And then I have on functions, I have from 0 to 4 cosine 2 theta. And then I have 1/2, which is z, the height of the cookie, 1/2 inch, let's say. And then r dr d theta. This will compute the volume of the cookie. This is some really awesome stuff. When I put 3 dots, you know exactly what's going to happen, right? You're going to go home and you're going to just crank the calculus 1 around it, because you just do the inner integral, the outer integral. If you run into any squares and sines and cosines, you will use power reducing formulas. So nothing special. You know how to do all this stuff. And yes, I do have confidence in you. Trying to find if there are any examples that could be dealt with. Yes. R equals. Thank you. I did not catch that. Supposed to say R equals. Yep. It's a polar equation. Right, so find the volume of the cone. Z equals 25 minus square root of x squared plus y squared. What do you do? All right, let's take a look at this. So we are going to have now the function f of r theta as 25 minus just r, because you have r squared under the square root, right? And as we are setting up the volume, we have the double integral of 25 minus r, and then r dr d theta. Don't forget, this is the string together. This r, it's a part. You're memorizing that. the limits. Let's see the limits. So as theta, we go 0 to 2 pi because we want the entire cone, not half or a quarter or anything like that. We just want the whole thing go around. And then the radius, you can see here, if you set it equal to 0, to find what's happening on the bottom of this cone, you will have a radius of 25, so 0 to 25. And then you just solve it. So we'll hopefully take a look at 1 or 2 more examples next class. So I'll see you all tomorrow.